All right. Well, thanks for having us, first of all, here, and thanks for everybody for coming. What we're going to talk about today is Knative, or as I like to say, just native, and the K is silent, but properly pronounced is Knative. And how many of you have heard about Knative more than just kind of a headline? Okay. How many of you have actually used it? Good, because if it was all of you raised the hands and all of you were experts, I would be like, what am I doing here? All right, so what I'm going to do is I'm going to do like a super 3 to 4 minutes quick intro of kind of history and what Knative started for and how to kind of rebasing everybody, and then moving into proper technical session and anything between 3 to 7 demos, depending how things go. One of those demos was written on a plane flying over here, so it might not work. All right, so Kubernetes, first of all, if you haven't heard, Knative is another layer on top of Kubernetes. Kubernetes was extremely, or has been, and still is, extremely popular. I just updated this today. 47,000 of stars on GitHub if you into measuring success of a project by that. A lot of companies on the bandwagon is moving heavy. For a lot of OpenStack, VMware, and others have tried doing this in the past, and by all signs of what we're seeing from Kubernetes is probably the platform that kind of modernized everything. Basically created a surface area where we were able to start expecting a very common set of behaviors from different environments. So if you deployed Kubernetes at AWS or on GKE or Azure or even on-premise, there is a certain level of expectations that you get from the fact that you're running above it. Similarly to what Linux did a while back, probably more differentiation at Linux than it is at Kubernetes right now. Kubernetes has a pretty strong conformance program with certification plan. So if you're running on top of Kubernetes, you can expect some of those things. I'm not going to read it. You can read just as much as I do, but there's a fair amount of kind of common layer. To a large degree, what Kubernetes created is this kind of smooth area. So if you're thinking about kind of writing your application on those rough, sharp edges, there's a little road that's paved for you, and it's pretty good. So what happened is, because of that popularity of Kubernetes and because of people were very successful kind of developing on it, people started using it for web applications, not just batch jobs like sending a container and let it run forever, but building applications. And if you kind of create this rudimentary set of tools like Kubernetes is, serving the kind of lower level infrastructure, but not really helping anything to developer up on the top, there's 50 different ways of doing things. So what happened is that serverless momentum jumped on a bandwagon and said, we're going to build serverless on top of Kubernetes. So you have an infrastructure and expectations of serverless, and those two worlds kind of, depending who you talk to, if you talk to the Kubernetes community, you will get of course, we'll build serverless on top of Kubernetes. If you talk to the serverless community who came from never thinking about servers or anything like that, probably from Lambda world, they would say, you already lost me because you're telling me about I'm going to be looking to build my serverless on top of infrastructure, and I don't want to know about it. When we started looking at it, I don't know, about 2 years ago, almost 2 years ago, because of what we have seen in the marketplace, we've quickly realized that serverless must be bigger than just functions. If you're thinking about shipping your code in a browser to some cloud out there and have it run, you quickly kind of come to to the limitations of that kind of approach. First of all, you're probably limited to runtimes. You're probably limited to the experience of the connectivity to that cloud. A lot of different issues. So serverless is definitely bigger than just function. And then as we start working on Knative, we realized that it's probably bigger than even compute. What I mean by compute, so if you think about in terms of Google, you have your App Engine, you have your Cloud Functions. Those are compute level products. You put your code in there and it runs. I think serverless is actually beyond that. So if you think about BigQuery as a product, so being able to run SQL queries through even browser if you're into that kind of thing, or Spanner or others, where you don't thinking about this. It's not a computing product, but it's still serverless experience. So what does serverless experience really mean at that point? So the first top left box, it's kind of gimme, right? If you're talking about serverless, it's less of service. There's no servers. So first of all, we got that checked probably right away. The notion of being able to pay only for what you use, which is more important when you flip this around by saying you don't pay when you don't use. If there is no utilization, you shouldn't be paying for anything. Event-driven, because on the end of the day, you don't want to write the amount of code you have to write, for example, to monitor a queue or to monitor a particular event, exponentially increase the footprint of the code you need to write. So that's not something we want to do. We want to create an event source and allow you to say, okay, when that happens, I want to do something. But I don't want to do anything else while that is happening. Because if you don't have events, it's very hard to talk about the other point, the pay for when you don't do anything. Because you have to monitor. Do you have something for me? Do you have something for me? Do you have something for me? And when you do that, you're doing something, therefore you have to pay for it, right? So events are critical. The part that's often omitted when you think about serverless and kind of watch the conversation in the open source community is this notion of portability. You have different platforms develop that solve the same things to a large degree over and over and over, and therefore creating a lot of duplication. So portability, I think, is one of the things that Knative kind of differentiates on. But when we, like I said, over 2 years ago, maybe closer to a year and a half ago, when we started looking on the open source landscape, what we've seen out there, the different frameworks and projects, there was at least 13, and depending on how you count, it could be even 17. Some of them have kind of been on the edge of what serverless was supposed to be. Of open source platforms, most of them were either FAS or PaaS or some kind of container as a service offering. Many of them are already on Kubernetes and many of them moving. So when you're developing a brand new project, the first thing you want to ask yourself, am I going to write n+1? Am I going to be 14th project that's going to do, I have 99 problems, now I have 100. So that's not what we wanted to do. So what we started doing is looking where people where were some of the common things that people were doing in the serverless space when they were building on top of Knative. And we quickly realized that I'm going to go over here because I want to point to my finger, hopefully not trip. A lot of work between the different frameworks was going into these, I would say, complicated but boring problems like autoscaling and invokers and builds and so forth. So a lot of efforts here, a lot of duplication because OpenFAS and Kubeless and everybody else had their own approach, and there was nothing else there, so basically they were building. But what was happening because of that, the areas where they were differentiating, how the developers were using those products, were actually getting less attention because everybody was focusing over here. So one of the things that Knative tried to do right from the start is to start thinking about our project as a set of ingredients. Don't come out there and say Knative or nothing else, but rather come in and say, what are some, like if you're cooking, what are the ingredients you can bring in? What are some components, lower level components that we can do? So we built this, we open sourced Knative in July last year with a few launch partners. I'll talk about this in a minute. But right from the start, wanted to be a project that would allow you to come and say, you know what, I like what you're doing in serving with regards to autoscaling, but I'm going to bring my other bits because I already have those. So not something that you had to take all or nothing, but actually being able to take it a la carte. So like I said, set of primitives. Right now, predominantly, it's built eventing and serving. You will see probably 5 or 10 other projects around it, but they're in the same space. There's not new space right now. There's new ones creating right now. For example, we have a client project that just kicked off, and I will demonstrate some of the components that are going to go into this in a minute. But to a large degree, those are the 3 areas: builds, eventing, and serving. It solves and focuses predominantly on modern development patterns. What I mean by that, if you follow the 12-factor application development principles, you're probably at home. But if you're going to be developing a database that doesn't listen to HTTP and it's based on some kind of batch process, Knative is probably not the right fit. The good news there is that because we sit on top of Kubernetes, when you fall over, when Knative is not able to meet your needs, you're not falling all the way down. You just go to the next level, which is Kubernetes. So you have to write a little more code, but you suddenly have to say, I'm not able to do what I need with Knative. I have to rewrite everything for yet another platform sometime later. It implements a lot of learnings from Google and other partners. And what I mean by that, you might disagree, but if you look at App Engine originally 10 years ago, more than 10 years ago, 10 and a half years ago, to a large degree, that was the first serverless platform. You brought your code, you ran it, you had you had to add a little manifest in there, but to a large degree it was serverless. Come on in. I'm not sure we have any more spots, but there's a couple there. So as you can imagine, over the last 10 years, we at Google, as well as all our partners, have been solving for how do you run somebody else's code at scale? How do you provide different runtimes? How do you enable people to upgrade their code while under load? The blue-green deployments. The SRE experience came in, so there's a lot of knowledge there that we brought in. And something that we did not foresee very much, but we're very happy about seeing, is that Knative became itself an ingredient for other people's platforms. So they were saying, I will take that and I'll build my product in it. And Sebastien will talk about their Triggermesh platform that is one that's demonstrating that kind of pattern. So before we go into demos, how am I doing on time? About 5 minutes? I want to kind of parse out two things. So I'm going to be talking about Knative kind of holistically, and you will see me doing things that sometimes fall inside of the persona of an operator, somebody who is creating things and running for another developer who's going to be developing on it. And sometimes I'm going to be the developer who's just using it. When we talk about Knative as a serverless platform, it's for the developer, the person who builds applications on Knative, not the person who builds Knative or deploys Knative or operates this on a day-to-day basis. So that's kind of what I want to parse out there. So for the developer, I spoke about this at Spring conference. Spring is like a big framework for Java developers. It's pretty popular worldwide, I think. The amount of work that you have to do nowadays, if you were to just go to Kubernetes and develop your application on top of that, it includes things like building your Docker image, first of all. It would include uploading that image to registry and making sure that's the right registry that's available from your repository. Deploying that service, making sure that's accessible to the internet, making sure the routes are managed and traffic and all that. So Kubernetes has tools for all of those, but that's something you would have to do extra, multiple steps. So if I am a developer, on the end of the day, I just want to write code. Just let me write my code. Don't tell me about like creating another framework for logging so that I can write my application so I can serve to my user. So I'm sure Sebastien, as a developer, probably says, no, I want to know about everything.
No, I said as an admin, I don't want to write code, I want infrastructure.
Yeah. All right, so this is the utopia, this is the goal. Can we enable developers to be able to write code and not worry about the infrastructure at all? So what are some of the things you have to do? First of all, let me just kind of quick recap. These were the launch partners at launch. I will skip very quickly. One of the things I've talked about before is that people took Knative and started building their own products. I don't know if you can see from the back there, but Pivotal launched their PFS service based on Knative. Triggermesh I already talked about. Red Hat with OpenShift 4. SAP had a open source framework called Kima that's based on Knative. Who else am I missing? IBM, Cloud Functions, and other components. So people took either all of them or one project, but basically took those ingredients and they cooked their own meal. Like, I'll go, pick up the pieces that make sense for me from Knative and build platform for it. And that's exactly what we want to see happening, because each one of those now introduce way of common builds, for example. To large degree, and we're working yet how to figure out the kind of validation of that, but to large degree, if you go and develop something on Triggermesh today, that image that is generated or that manifest that's generated from it, you can take that and you can bring it to Knative hosted on GKE and deploy it, and there's a high probability. I'm not saying 100% today just because we haven't introduced the conformance program yet, but there's a large probability they will just run out of the box. So portability, remember to that box I was talking about, that's very, very critical. I'm going to skip through this. This is just people love us, basically. The one thing I want to highlight in here, so T-Mobile is probably not your, not like the others. It's not like SAP or IBM or even Triggermesh, right? It's a company that you probably, I'm on T-Mobile on my phone. They themselves were developing a platform. They saw Knative, they stopped that, they re-platformed everything, and they were a launch partner with us. They demonstrated their internal platform built on Knative. That's probably as good of a validation from enterprise company as we're going to get. All right, enough slides, right? Let's do some AKA demo time. So first of all, what I'm going to do is, and I'm going to kind of be switching back and forth here.
Take your time because I spoke all day, so I can give you.
All right, all right. So first of all, what I'm going to do, I'm going to show you just get this out of the way. You already build your images. You're saying, don't tell me I have to rebuild my images. What is the quickest way I can run? Hold on a second. What's going on here? There we go. For some reason, my keys weren't working. That was scary. All right, so what I'm going to do, oh, that's not it. There we go. What I'm going to do is I'm going to use an open source library that's actually developed by somebody else. One of the things, question? Yes, yes. Oh, so this is different on this screen than it is on this. Is it readable? Is it good? All right, so one of the things that when we first started on Knative, because it came from Kubernetes land, you interacted with Knative through, guess what? kubectl. So if you were familiar with Kubernetes, you were at home because you didn't have to learn a new CLI. You were able to just simply use a different set of objects that were kind of abstracting and giving you much easier set of constructs that you can reason about, but you didn't have to learn everything. Well, that was great for the people who came from Kubernetes, but people who came from, I'm a web developer or application developer, I want to write something, we didn't want to force them to learn kubectl. So what community has done is start developing those CLI tools. One of the Dimitri from Pivotal wrote Knackle. It's KN for Knative, CTL like control, right? It gives you a simple interaction. What we're going to do here is, Knackle has a number of commands. We're going to do Knackle. Let's actually do this. Let's do just to show you what you can do already with this. There we go. You can deploy. You can manage your services. You can connect certificates. Basically, kind of the thing you would expect from other ones. Google also introduced that similar set of components inside of the G-Cloud. So if you were hosting Knative on GCP, you can use G-Cloud just like you would do with all the other things for GCP, like VM provisioning and everything. It's just G-Cloud, serverless, and then you're good to go. But I'm going to use this one because I like to use open source community tools when I'm in presentations. And I need to find this command again. Let's write it from scratch. Deploy. All right. So what we're going to do here is we're going to Knackle deploy. We're going to say the type of service. I should have used the long flags here, but S stands for service. I'm going to call it Simplo because this is demo. I'm going to say image, and then just pointer to URL to where the image is already pre-built. So if you have a GCR already, image is hosted somewhere, you're good to go. I'm going to create environment variable called env here. Actually, even that can be shortened. We're going to simple message and then hello Zurich, and the namespace we're going to deploy is demo. So Knative, just like Kubernetes, supports number of namespaces, so you can isolate each other so you don't fight with URLs. If you create an application with the same name like mine, we need different namespaces. You don't have to decide who's there first. Oh, I'm sure somebody's paying attention here. All right. So if you're an application developer, you don't have to learn Kubernetes. You come to a simple command line. There's actually UI applications for that now. GCP has kind of a way to upload the image and run it. And Sebastien is going to show Triggermesh, the cool UI that's even better than that, gives you a lot of flexibility there. Basically succeeded. So I have my Knative instance configured with knative.tech domain. So everything I publish automatically goes into demo. because that's the namespace I'm in, and then the name of the application. So in this case, we'll see hello Zurich, it's automatically. Now, that's boring, right? You run just a command. Come on, don't clap for this. Okay, good. What just happened is you just did one command, that's cool, whatever, like Docker maybe could have done the same thing. But you deployed that image to Knative, and what you got for free from that is stuff like auto-scaling, auto-reconciliation. Suddenly, let's say this Hello Zurich application is the most popular application, just got front page of Hacker News, and you have just got slammed. You don't do anything. If the physical resources are there underneath, it will just start auto-scaling. And guess what? When your page is no longer on the front page and suddenly you have only one user a week coming over, it's going to go down to 0 and it's not going to consume any resources until it's being used. So you as a developer never even worry about the infrastructure. All right. That was boring. Let's move on. I wonder if I can just stay in here. Can you guys see this? Yeah, I'll stay in here because if I go back and forth, it'll be blinking all the time. But developers, we said, want to write just code and don't worry about anything else. So let's go back to, I have a simple example, source to build. So what we're going to do is, I'm going to actually switch to, kubectl now because we're going to do a little more complicated things. So what we're going to do is we're going to set up a service that's going to go to a GitHub repository, pull that code from there, bring that to the cluster itself, provision the resources required to build that application, deploy the application, and then destroy all the resources. So during the build, you need some extra resources on a cluster, but after that, you're good to go. Can you guys see this? Oh, this is probably too big. Hold on a second. So before I run this, I want to walk you through this. I'm going to call this application source to URL, very creative. I'm going to still go to my demo. I'm going to point to the repository I'm going to want to build that code from. I have some branches there, but for purposes of the demo, we're just going to go through the master. Don't do that in real life. What we're also going to do is we're going to define when the image is built. We want to publish that to registry. In this case, I work for Google, so GCR. But it could be Docker if you want to push it to. We're going to define a variable. This is in YAML. If you're familiar with YAML, you can use it. If you're not, you might as well just copy and paste it twice in here. But in this one, we're going to use that variable later and just say whatever the URL is up there, we're going to apply it over here, and then we're going to have some message in here. So let's go back. Clear. Where are we? All right, so the source apply, what do we call this in here? Up. All right, so this is probably going to take a little longer. Maybe I'm not connected to the internet. There we go. So I will come back to the manifest in a second here. But while this is building, let me just make it a little smaller. Can you guys still see it? I hate when it wraps around because then it's... Yeah. You can see one service over here that's creating. We can actually monitor it. Describe pod. It's pulling images, it's doing something. If you're a developer, you literally just apply your code to a Git repository. Like you never deal with this, right? Your operator says, hey, the tests have passed, hopefully. Everything is good, I'm ready to deploy. They would just pull the trigger on this, and this whole thing built behind the scene. So let's it started almost.
Can you also describe the service and see the status there? Is it updated, the status?
When the build process creates an image, then it will do, yes. And we'll do this in a second. But so in here we see 2 out of 3 steps. So the first one is pulling the code. Second one is bring in the infrastructure to build the code, because it doesn't exist, because it's scaled to 0, right? To bring the infrastructure, then load that code into that build process, and then build it. While this is doing, let me do this. So if you go to Knative, oh, it's on GitHub, right? Today, when I'm building in here, I'm actually using a library that we have, like a build template. So Knative supports a number of different ways of building things. For different languages, you might get different optimization. For example, for Java, we have an open source library that's called Jib that does some really clever things around like rearranging the content of the container so that when you switch one dependency in your Java application, Spring or Java itself will download half of the internet at that point, right? Because it needs to do it. So you don't want to push that image because suddenly the entire image has to be refreshed. Every single layer has changed. So what Jib does is aware of how Java works, rearranges those layers, and then when it builds image, even when you have dependencies, it will know, oh, only this one thing's change, and it will do this for you. So we have a project called Build Templates, which goes with the build itself. So today I'm using the Canonical build template, but you see Jib in here, you see there's build packs. If you were coming from a Cloud Foundry world where we do like auto sensing for applications to know which version of Node.js you're using or something like that, you choose the build templates that you want, you run a build file, and it's done. Well, let's check on our. All right, so we have our Surya. So what's going in here? So I'm going to trick myself. So our build job finished is completed, and what Knative will do, I have it on for demo purposes. I have it to live around for 2 minutes. So I can actually show you, but normally it takes like 30 seconds, and it will just go. I'm done. So this one is done, and it just deploy one of the services called the exact same name, and it's already running here. So let's go to source to URL. Well, you know what? I'm lazy. You tell me if I misspell something, right? All right. So images? What images? I don't need it. I'm building it right from scratch. You can do two things. You can do either if you want a little control, you can put a Docker file in your repository, and you tell us how to build exactly. And what we in that case do, we say, you have a Docker. You already told us, bring it in. If you don't have a Docker file, like for example with this Java example that I do, what we will do, we will apply the best practices that we know. So we'll build the image right for you without even the Docker file. We'll sense it, this has package.json. Okay, that's probably no JS application. Let's go and build it for you, right? By the way, ask questions and don't hesitate to wait for the end. Anybody?
Is that a Knative feature or a feature of a specific builder container? That I could,
So Knative has the infrastructure, the shell for builds. The build packs, the build templates orchestrate how this build is happening. So Knative say, you told us to build using this template, let's bring it in and orchestrate. And I showed you this library. There's what, Bezo, one of the most popular one actually. Nobody really talks about it, but it's pretty popular in the industry out there. You have Builda, because you gotta have the cool name in your build packs. Build pack, you have, I'm not sure what hack is, somebody put it in there. Jib, Canonical. Pivotal did build a couple really cool ones for languages that we don't have really expertise internally, like C# or visualbasics.net, if you intend that kind of thing. All right.
How do you use Maven or Gradle? How do you compile the Java application?
So in case of Jib, it will use Maven underneath, yes. So Jib has a definition how you do it. If you put a container Docker file to tell us how to build it, it will build it. Otherwise, it would just use like whatever Maven principles are. I'm not really a Java developer, so I can tell you.
So quickly, this is a GitHub constant, right? So you're deploying to one environment, right? You're starting the job deploying. How do you promote between environments?
Do I have a demo for you? Wait just a minute.
And is that like an overview, like a view, right? You can see the whole process and how do you handle concurrency? So when a couple of developers are committing to master, and you have a couple of good jobs executing, like, can you stop the previous one, or do you block and stuff?
So two-part question, actually. So first of all is how do you differentiate? So basically in Git, you have a commit, which has a unique identifier. So obviously you can relate to who is who. How do you stop them from fighting? Let me show you. So this is built inside of Knative. We've brought the code into Knative. We build it for you. But you say, you know what? I've been in this software industry forever. We already have a build system. So let's imagine how this looks like. Go ahead.
Basically, Knative is compiling and executing our code, or is compiling a Docker image and executing?
It's always image. Doesn't matter where it came from. The unit of delivery is an image. So all those tools, all those build packs, they do their magic, but on the end of the day, there's an image. Because image represents point in time code snapshot. So if you have a version, we will build a new image and push it. And it becomes important when we start doing like promotions, which I think you were asking for. How do you do blue-green deployments or canary pattern? And I will get to the demo. I'm also excited because I'm actually right on almost like as if I paid you to ask the question. So what we have here is a repository that I built my code in. You will see my commits. I'm the only one building, but normally you would have developers there, right? So let's say you developers building everything, pushing code, the code it's tested and everything. Eventually, your I don't know, build master or build operator, whatever you want to call it, says, I want to deploy this one. So what we're going to do in here, you can see I was testing my releases. So what I'm going to do is in here, I'm going to do hopefully you will have better comments and everything for this. But what I'm going to do is I'm going to simply just save a new tag. You can do it from command line. I'm just doing it through UI. You create a tag locally and you commit the tag. And a tag goes with a commit in a code. So it's like only one person, it's a transactional process. Only one person can do that at a time. When I've done this there's no Knative in history here. You can do this with Cloud Build. You can do this with Jenkins. You can do this with Concourse from Pivotal. You can do with a lot of different CI/CD tools. What happens behind the scene, and I'll show you here while we're waiting for this to build. What happens behind the scene, there's just normally you wouldn't keep it in the same repository, but I'm lazy, so I put it in here. There's just a job that says, I'm going to run another set of tests. Can you guys see this? Let me try to make it a little bigger. I'm going to run another set of tests, make sure that it passes, because I might have broken something in my test infrastructure. I'm going to then build an image. I'm going to push that image, and I'm going to deploy it to Knative. So we create a manifest, replace a couple of variables, and deploy it. This is all using G-Cloud. So for example, you would think I would know the URL for.
To Google the cloud install URL.
I have limited space up here.
Cloud.google.com.
I only remember the things that I need to remember. So what we have here is a trigger that's monitoring for a particular release tag with version in there, variable. And then as soon as this is done, it's deployed. And you know why I know it's done? Because it sent me, you can't see it from here, but it sent me an alert saying your build is done. Or if it failed, it would send you an alert here. So let's take a look for this. So I have this, what do we do over there? Was it 43 or something? Yeah. Bottom line is it wasn't 41 for sure, right? Okay, there's a 43. I, as a developer, did nothing. Everything was, I wrote code and I committed. The tests told me if I did a good job. The operator let's say you don't deploy on every single release. You do it only on Mondays or Sundays because it's low time or something. Your operator decided, okay, when this happens, I can run these tests and I can deploy it. All of this was done for you. Question? This one I want to clap for because it's pretty cool. And I wish I could show you the notifications. I was using Slack notifications, but I don't want to spam the entire team for it. So I don't know if you guys know about this pushover application, mobile application called pushover that aggregates notifications. I just refactored this today for pushover, so now it sends from builds. Cool. How are we doing on time? Let's very quickly go here because I think this is actually interesting.
May I ask you?
Yeah. Oh, sorry, I didn't ask you a question. I apologize.
So, as you will come into events and other concepts, are you trying to deliver a replacement to CI/CD systems?
No. So I'll be the first one to admit that what Knative. Oh, the question. Are we replacing CI/CD tools? You can go to your Jenkins friends and others and tell them, worry nothing. What Knative works under one principle, and one of the leads, one of the original people who kind of thought about it and created kind of the original concept behind Knative, a guy named Ville, he keeps talking about this notion of batteries included. Like you install it and everything is there. It might not be the best way, but everything works out of the box. But one by pieces you include it. So this is the same principle. You have, if you don't deploy the Knative build at all, you can integrate with your own build pipeline. And your Knative cluster is smaller because you didn't install the builds at all, right? If you want your builds just for the kind of starting point, you can start with this and graduate to CI/CD. But there is no ambition to build a full-blown CI/CD. It's more about optimizing the build itself than it is dealing with the developer experience. So you will probably not see the build tools from Knative kind of solving for reports or something like this. Nah. All right, so what do we see here so far, cluster and builds? People like that a lot of times because I'm building on a Mac. Thankfully, Kubernetes on my cluster doesn't run on a Mac. So you would have had Docker locally, and there are some security implications with that because Docker runs, with God level privileges. I would have to remember how to switch those flags to say compile on a Mac but build for Linux. I would have to also deal with the fact that my build might be massive and my little laptop has only, I don't know how much this, 8 or 16 gigs of RAM. In a cloud, you heard about the fact that cloud is like limitless. There are the resources for everything. So you build, you use what you need, and you're laughing, but companies like gaming companies, their builds take like 24 hours. They can get a lot of benefit by shipping the code to the cloud, provision hundreds of VMs to rebuild it for them, and then kill those VMs and be done. So Knative gives you that flexibility. And then it's got a very nice plugin. So for example, there is all of those build components are extending CRDs, so you can use RBAC rules to prevent it. So we can actually create a cluster where you as a developer will not be able to see anything. You only see the Knative API, which is 3 simple objects. And one of the strengths of it is service, configuration, and route. If you were building web applications, that's all you need to know. When we come to events, you might be additional ones. But behind the scene, there's a lot of different things, and you didn't have to worry about it. And if you grow up, you can always replace it with a CI/CD, so it's not like a lifetime commitment. You're just saying, I will start with this, see how it works, and then move on.
Okay, so, excuse me. So you're practically saying don't run Docker locally as a developer?
No, I would.
I'm exaggerating.
Yeah.
So you just write the code and you commit and push, and then you're all done. So okay, now imagine the build fails. So how do you? Can you show how you debug this?
Yeah. So depending which one you use, if you use the Knative build on cluster, all of the logs go into logs, and if you're running, let me show you.
It's really, just to cut this short, it's not really just getting the logs. It's you're troubleshooting, and when you're pushing the next change, you get a new commit, and then you have all of those commits.
Yeah.
Try to fix it. Fix it again. Fix the bug. Fix the syntax.
No, I get it. I get it. Do I need to repeat that question? Bottom line is, Knative solves for the builds, but doesn't solve for what comes after the fact. Nobody builds 100% proof code. There's always some bugs. And and I'll be the first one to tell you, if you have these kind of needs, your CI/CD tools are very common, your best friend. And Jenkins, if you're using Jenkins, Jenkins X out of the box comes with Knative compatibility. So you can actually build your normal pipeline, how you're using right now, and just connect it to Knative. And Knative does provide the information back to Jenkins, so you see all those things that you ask for over there.
No, actually, I think it's the other way around. I'm not happy with Jenkins because it's the same problem. If it's called Jenkins, GitLab CI, whatever you call it, Travis. The problem is that when it runs on your build server, you need another commit, and then you need to wait for the build to finish. So the good thing of having Docker locally or Minishift locally or Minikube, whatever, is you can try everything locally. You develop locally, you try the entire application on your machine. And then if you don't have enough RAM, buy a new machine, sorry.
So
you can have GitLab locally as well.
Okay, now let's not talk about this.
Yeah.
It's of course.
If you use case calls,
build problem. It builds. It's slower to build than to just.
that's a valid concern. If you build process requires, or if you are not comfortable with unit tests, integration tests that you've created, there's nothing stopping you. Absolutely, run Docker locally. Create an image locally. Even don't use our build process. Stay where you're comfortable and use it. When you get to the point where you have n number of developers building this entire thing, and nobody should ever create the entire thing on their machine because there's frankly no laptop big enough to ever run it, maybe you migrate it then. But you have options. So I'm not saying throw away your Docker. That's not what I'm saying. I'm saying that there are some implications when you start using this that you have to be aware of. All right, how are we doing on time? You okay with me?
You're getting short.
Okay. Let me do one, the blue-green, and I will skip through the rest because this is actually pretty interesting. So what we're going to do here is, let me just close this. Man, I was ambitious with my things. So what we're going to do here, just like the other service I showed you before, let me close this here. Just like the other ones, you're creating a normal service and deploy it. Knative has lower level objects like a revision, configuration, and oh my gosh, I need my coffee, and a route. But it also has this higher abstraction object, which is called service, which is one thing that kind of comprises all of that. So what we're going to do here, let's clear this. Where are we here now? CD to blue. All right. So what we're going to do is stage 1. All right, we're going to deploy our the first application, which was the very one I showed you before. No different than all the other, the simple demo or anything. You deploy your application, whether you've done it through command line or you've from a manifest, it doesn't matter. All right, so. Should be already there. Blue-green is deployed and running, so let's go here. Blue, I need to copy again. Demo. I usually work on a different profile, so none of the URLs that I normally type it are here. All right. You super duper app, V1, you deployed it, you're successful, everything is hunky-dory, now you're popular again. So you have users using it all the time. How do you upgrade it? Common question, right? You have to start dealing with things. So the first thing you want to do, this is a concept that Knative, is important you realize that. When you tell Knative, Knative is declarative. So when you tell it to create this application and make sure that it runs like that, it will make sure it runs like that. If I went in there and I deleted the pod or deleted the route or deleted any of the objects, it would recreate it right away. Like it would be saying, nope, you told me to do this, I'm going to do this. So the first thing we're going to do, we're going to change it from automatic to manual. We basically say none of these other configurations are required. I'm going to switch it from automatic to manual. So let's apply this one. So Knative will stop fighting us, so we can actually start making changes. All right. Nothing changed. You can still call this guy here. It will run. What we're going to do now is day 2, the common day 2 problem comes down here. You have new version of the code. This one is going to be called green. Very clever, right? It's going to be called green, but I want to deploy it and make sure that it runs well without sending any traffic to that new version. I just want to make sure that everything is hunky-dory. So remember I told you about this route object? So it's very logical, like there is service and there is route. You don't have to learn about some fancy objects. If you're a web developer, you probably dealt with routes before. So what we're going to do is we're going to keep that blue 100%. We're going to deploy a second application, but we're going to send 0 traffic to that version. And just to allow us to pick like manually, as explicitly by human at the new version, we're going to create a named route called V2. So let's apply this. Stage 2. Okay, so Kubernetes is complaining, saying, you didn't manually create this object. Somebody else created. You editing an object that it shouldn't be edited. But we told it manual, so that's why we can do this now. So let's go back. Our V1 continues working as advertised, right? What we got now is named route that goes to the new version. Nobody else goes to it. So you can see, oh, looks okay. You can block it on your API gateway, say no external public can go to it. I can just go to it, right? So this is all good. You go through this, make sure everything is good. Hopefully you wash, rinse, and repeat a few times. Then we come in and we start. So we have our 2 revisions. So those 2 instances that comprise of your configuration and your code. They running, both of them. One of them is taking 100% of the traffic, the other one doesn't. What we're going to do now, normally you're probably going to do more gradual, or like you're going to for 1%, 10%, 15, 20, whatever. For purposes of demo, we're going to go right into 50-50, so I can refresh very easily here. We're going to keep our V2, but we're going to start sending half of the traffic to one version and half to the other. So let's apply it at stage 3. And again, this could be all done with your CI/CD tools based on metrics, because it's not something that you have to involve human into. So now, V2 is always there. And it's not exact science. Let me see. I want to make sure the other one's running. Okay. So we have our 50%, right? Now you gradually increase it. Suddenly you say, you know what? Half of the metrics coming back from the new version are pretty good. We solved the problem that we deployed the new version for. So let's migrate everybody there. So this is a really cool part in here, because what we're going to do is kind of flip this upside down. We're going to keep the old version around in case we find a bug and we want to revert this whole thing over. So it will still be there. Won't be using any resources after n number of minutes. On my demo, I have 2 minutes, but by default it comes by 30. You can change that. And we're going to send 100% of the traffic. But in order to allow human to compare this side by side, if we wanted to, we're going to create the flip side, which is the V1 for the old version. Did I apply this already? No, I didn't. Sometimes I get lost in those demos where I am. All right. So now, the V2 takes 100% of the traffic, and we can go to V1 and peek at it. So this was a poor person's blue-green deployment pattern. Normally you would have metrics coming in, all of this happen automatically. Even Google does it, right? We deploy globally, so you have like 5%, 15 or something. Hopefully not blowing your mind with how we deploy software here. All right, I'm gonna go quickly through a couple other things. So why serving is important? First of all, you as a developer never worry about scaling up or down. It wasn't like, hey, we have 100% utilization, we need some more resources. You have a cluster, you can even have automation to provision the underlying VMs. When my cluster is getting to a certain level, I want to provision additional VMs. Knative will actually, if you give it a policy to allow it to do it, it will provision those VMs for you. But right now, if you have to spill over to a new VM based on a request, it will take, we do what, new VMs at 3 minutes now? So it will take you 3 minutes. You don't want a user to wait it, right? So you would want to say, oh, when it gets to like 70%, I want to start provisioning a new VM. So all of that happens. Similarly, on a way back down. So no utilization, we'll start scaling the pods automatically. So that happens transparently. But even the VMs will go away. So if you had a burst and you use 100 VMs, and then we scale all the pods, Kubernetes realized, I'm not using half of these VMs. I'll just start disgorging, killing them, basically. I was looking for a fancy word, but with lack of sleep, that doesn't come very easy. Built-in traffic splitting, it's manual what's built in, but if you're using CI/CD tools, you can promote this based on automation. You have mesh integration automatically. We didn't show this, but you can actually go to Istio and start seeing inter-service connectivity. You can assign routes to it, easy to reason about objects. Again, if you're coming not from Kubernetes, that there are 3 to 5 objects, depending how much of a build you want to know about or eventing, that you have to know. And they're pretty simple. Like if you think about service, if you're a web developer, you probably know about it. It's pliable also, so you can bring in your own custom autoscaler. The one we deploy by default with Knative is based on requests per second. So this is not your standard CPU-based utilization autoscaler that Kubernetes comes with, where you're saying if you have a CPU utilization, then provision another pod. It's based on a request because that's a web, right? Your disk access might be nominal, but your traffic is huge. So based on a request, we scale this for you. But you know what? Let's say your application has a connectivity to the database, and there's a connection pool to Oracle, God forbid. And you have to go through this. So you might actually use the connection pool metrics to scale it and say, I want to provision n number of resources for that. And it can be tuned and customized. If you're looking for like an Autoscaler overview, Joe, one of the leads on Autoscaler, and I did a really good session, I thought, personally, at KubeCon in Seattle, and that got recorded. And has custom autoscaler metrics, has all kinds of autoscaling. Just look KubeCon Seattle, scale from 0 to infinity. That should be easy to find. There's an IoT demo, but Sebastien is rushing me here, so I can't finish this. If you want to see this one, look at San Francisco Next videos, and you will see me doing this. So this is, Google has an IoT core product where you go to the UI, you create a IoT gateway for MQTT and other protocols, and it manages the securities, keys, device management, and all that. You go to UI, you create this. What happens on the back end, it pushes all into PubSub, and we create a trigger on Knative side and say, watch this PubSub. When something arrives, bind it to a particular service. Here's the beauty of this. That service knows nothing about IoT, knows nothing about PubSub or Google or anything. It's a normal code. If you want a Python, Node.js, or Go, you write it because we pass that object to you. So you're saying all the plumbing is done for you. You don't have to know about it. So if you want to replace it, you can just replace this with different logic and assign it in a glue, and it's all good. And so I scales from 0 to 1. Another good demo. You can Seattle KubeCon. If you walk away with nothing else, these are the 3 things I would like you to remember about Knative. First of all, it's easy to deploy. If you're using GCP Cloud, you can go to the UI. When you provision yourself a Kubernetes cluster, there's one extra checkbox saying, give me that Knative thing. Done. If you don't use GCP, very quickly, what was so funny? Did I type something? This will, I would like to show it because, you know, I like to be a good citizen of the community, not just always a Google employer. So you will see instructions for deploying on Azure. I have no idea what Gardener is. GCP, GKE, IBM Cloud, Pivotal. And if you going somewhere else, more exotic, you just go with the Knative on any Kubernetes. It doesn't assume anything about networking. So all the other ones have like, how do you provide a static IP on this cloud? So it's specific to that cloud, right? But if you go with the basic Kubernetes, it will just say, tell me what is your static IP, because I want to route some traffic to it, and it will install it.
OpenShift, it's included already in 4.0. You did.
So Red Hat OpenShift 4.0 is based on Knative, and it has a Knative API. They did a great job at KubeCon demoing and everything. They took the responsibility for making sure the components are right and deploying them and everything. If you were to treat OpenShift purely as a Kubernetes and you want to install your own, you can still do it because it's Kubernetes underneath. Yeah. So it depends how much customization you want. Good. All right. Sebastian, 1 minute. All right. So autoscaling by default, manage workloads is good. I can share later this deck with you. A couple of things about pluggability. One of the big things for us, it's pluggable, loosely coupled on top, so you can bring your own components. For example, eventing and routes, it's something that are executable because one of know about the other, but they're not connected strongly. So you can say, I want to send my data to a channel, like a queue, or I can send to a service, and that's the Knative eventing can do that because both of them look and quack like a duck, so to speak. And what you can see is that function riff and Red Hat kind of implemented their own bits for it. And it's also pluggable on the bottom. So you don't like our caching, bring your own caching. Replace it, good to go. You don't like our build process, replace it, do it. If you don't like our networking, remove Istio entirely, replace it. Solo.io did a gateway that is much smaller than Istio, and they kind of are compatible with it. All right, let me leave you with this. Bunch of URLs, documents. If you haven't seen those, there's a lot there. And I'd love to hear how you like it.
Questions?
Yeah.
So I saw a talk by Sebastien maybe a year ago.
I can't comment on his talks.
Here in Zurich, I think it was.
Really?
Yeah, there was a couple of us in the room.
Okay.
And I think the biggest problem with this was the long startup time, right? Of a container. So you were talking about caching, and I'm guessing this is something that you solve it. So how do you do the caching, and how do you over provision containers? Like how do you, if you use like something that starts very slow, like interpreter language, how do you make sure that when you need a resource that it actually is on time, right? You don't have to wait for it to spin up.
Yeah. You're going to love that session from KubeCon, by the way, because we talk about real-world scenarios. So right now, on my cluster, because of the type of VMs I provided, I'm probably dealing about like a 15 seconds cold start, which meaning I don't have anything on a local node, has to download the image, provision, and run it, right? For some jobs might be okay, for some might not. If you're not comfortable with that, what you can go in here in the Autoscaler and just define your scaling policy. So in here, you would just insert min scale, and you provide a number. Like if you put 1, it won't scale to 0. We'll always keep 1 or 5 or 10. You can also say how long you want to keep in autoscaling configuration. You can define how long you want to keep that cold one around for. So that's all good. What we also do as part of Knative community is solving for that cold start so that even that wouldn't have to be configured. Like it's not going to be one silver bullet that's going to change it suddenly and there's like split of a second, right? It's going to be 20 different things working on it. But I can tell you right now that the way we as a whole community building images that end up with a 600 meg Java application, it's probably the #1 contributor to it. If you're following some good process of builds and kind of do a 2-phase build on a Docker image, you can get them a lot smaller. They will increase the performance, but it's still not going to go to like a sub 3 seconds.
One last question. You are now at version 0.3 of Knative.
Yep.
Would you say it's safe to run it in production as today?
My answer, as any technologist would always answer, would be depends. and I mean that only slightly in a joking way. If you depend on a serving alone, you have your own build, you don't really need too much of the events. I would say there are some companies who are building already or introducing this in production. If you're going, build is easier because build fails, you redo it, so it's not a real-time thing. I think the eventing is the most exciting part right now because we had to kind of take a step back to bring the community back together, figure out how we want to create the events hoops, and Sebastien can talk about that. And then as soon as that is done, 0.2 introduced the new eventing base, and 0.3 introduced the new events. So I would say for events, probably don't go to production just yet. We are on a 6-week cadence now, so you could imagine, I'm not sure that there is a rule that every one of them has to be a .1 incremental, but you could imagine that in 2-3 releases, we'll be pretty good. We finished with this. Number one blocker for us to actually call this, is ready for production grade, is frankly a ability to upgrade in place. Because we are pretty comfortable with what you're going to bring on a day one, but as you're using it and we come up with a new version of Knative, how do you do this in a rolling upgrade so it doesn't bring you traffic and all that? And number one blocker there is lack of support or alpha only support for versioning for CRDs. Everything in Knative is CRDs, right? So until we have versioning for CRDs in Kubernetes, at least in beta, I wouldn't do it. So if I kind of did this and I had to guess, I would say 6 to 8 months maybe before we would we'll call it a full kind of 1.0 version or whatever that means. Similarly to what Istio, Istio still has significant gaps, but they felt like at that point it was a good enough product. All right, I don't want to steal any more time. Did you have a quick one?
It's more high level.
Sebastien can answer high level.
Can we do that after I speak, because we have to go to the speaker dinner for container stack.
Right.
Thank you.
Thank you.
Okay, I'm gonna get started. Yeah, it's only gonna last 20 minutes.
That's what I said.
Yeah. Are we good? Cool. So first, thanks. It's great to be here. Thanks for vision. I really struggle. How do you say it, Marcus? Vision. Okay. So thanks for having us. Thanks to Arno for hosting us. It's great. To be here. I had the chance to come here like 10 days ago, maybe, or 2 weeks ago. I worked with Tobias on installing Knative in OpenShift, and then installing Triggermesh. And Tobias is really exceptional, so it was great to be here and work with him. So I'll be short because Mark has already done, set the stage a lot about Knative. He talked a lot about the build, about the serving. And then I'm going to talk about events, right? I don't think we talked much about events. I would like to show you a few things about eventing in Knative. But first, there was a question about kubeless. So I created kubeless, I think it was December 2016. It was one of the first FAS on top of Kubernetes. It's still going. It's a project that's working well. The time to start that was mentioned is indeed the cold start. And optimizing the cold start is a big thing in serverless. In kubeless, it was not that bad. It is not that bad. It's just that we didn't want to do a build. We didn't want to do a Docker build like Knative was doing. So we started with a way of injecting code directly in running containers and doing kind of the build in place, if you wish. It worked great, and it works great, except if you have lots of dependencies that you need to install. And then, the initialization of the container needs to get all the dependencies, and then, it takes a bit of time for the container to come up. If you don't go with this strategy, you do a build, wherever, locally, remotely, Now all your dependencies have been packaged. You can also deal with compiled languages. That's great. And then you just deploy that, right? So then the start for your app is going to be, much faster. So anyway, you were gone. I answered your question. No. But now, now that Google started Knative with all the partners, and Gartner is from SAP, by the way.
Oh, is it?
Yeah.
I'm sorry.
So, it's definitely going to be those solutions where all the FAS technologies should really concentrate, and we should all build on top of Knative. And during the workshop today, we did an install of the Knative build system as an example of a CRD-based project, right? So, with that said, Mark showed you a lot of kube control. He showed you some manifest and so on. This is not, it's going to look like I'm pitching Triggermesh, which is my new project and my new startup. But I'm just going to show it to you to show you that you don't need to write those manifests and that YAML, right? There is, of course, a CLI. If you want to use it, you can still do what Mark has shown because we are exposing the API. But if you're in the spirit of let's try to make something extremely easy to use for developers, maybe you want to do things a little bit differently. So here I'm on the interface. You can get an account. Actually, it's up and running. If you want to create an object and you're still low level and you know what you're doing with the manifest, you can just paste that YAML object that Mark was showing you. And as a matter of fact, what I'm going to do is I'm going to go to his own project. K-test. I'm going to.
You want to run?
What? You bet? How much? How much?
I wrote it, so I couldn't.
How much? I'm going to just remove the namespace, okay, and I'm going to click create. We upgraded to 0.3.
Nice.
That's why it's running. So I'm just pasting the YAML, and now the container already exists, so it's fairly quick, and then it gives me a route. And boom, I get to my app, okay? So that was like, 10 seconds, really quick, but there was no build, right? But is that your app?
That's my app.
That's your app, okay. And then you can click, and I have no clue what it returns, but,
Very quickly, it's actually, Knative publishes a serverless container contract, as in, if you adhere to those container requirements, there's a high probability it will run everywhere. What this application does, it checks against those specifications saying, do you expose the limits on how much memory we gave you, or stuff like that.
Yeah. So under the hood, at the end, the Knative service does create a Kubernetes pod, so we can see the pod in the interface. We can get the logs of the pod. It's all good, right? If you want to create a service, you don't want to stick that YAML. We are giving you the option to access an image catalog, so pre-built images. And here we're just going to showcase that you could do this with existing images. So this is the catalog from OpenFAS. So if you're used to OpenFAS, this is the OpenFAS catalog. Node info is an OpenFAS function. I just create this, okay? Time for the route, to appear. So, okay, refresh. Now I click on it, and boom, I get the answer of that node info function. So it's pretty, it's still pretty quick. And if I check my pods, I do have 2 pods running. Okay. So that's fairly straightforward to launch. Now, if your app you haven't built, okay, we can create an app from a repository. And I'm going to use, again, Mark's project. It's not to make you.
Accumulation day.
Yeah. No, but. So you're not going to believe this, but I always use this repo as an example. We'll see if it works because we have problem with the registries, okay?
It's called Simple App for a reason.
Right, Simple App. If we look at Simple App, it's some people are going to say, well, that's not serverless, okay? That's a Go app. He actually wrote a Docker file, so he has to understand Docker. And that app, there is an HTTP server there. So he's right. Is there an HTTP? Yeah, there is an HTTP server. Yeah, here you go. So there is an HTTP server. Even if in Go it's easy, you're writing an HTTP server. You're not really focusing on the pure logic, right? So that one, I'm not sure if it's going to work because now we need to do a build, okay? So we need to do a build. So we go in the build history and we see that there is a build happening. And this build is using the Knative build system. It's using this template that Mark talked about, which is a Canico build. So it sees the Docker file. It's going to do the build inside Docker. And then it's going to push to the registry once it's done, right? We are struggling a little bit with our internal registry, and sometimes it's a little bit unreliable, okay? But we'll wait a little bit for that build to happen. Now, to make things a little bit, that's nice, but now to make things a little bit more integrated, what we want to do is say, well, the developers, they really work on GitHub or Bitbucket or GitLab. That's where the code is, right? So here, I'm going to say, you know what? I have a project that's called Cloud Build on GitHub. And because I logged in with GitHub, it can get my projects and so on. So now, I'm actually going to, here I define the build, and that's using pure Knative build. So it's true they don't want to replace, Knative doesn't want to replace CI/CD, but you get a poor man's CI/CD with the Knative build system, okay?
Poor person.
Poor people. Okay, let's call it poor people. So here I have my repo. That's what Triggermesh does. It's, we register those repos. Now we look at the build. First, Mark's build is still going. It's probably our fault. But the build that I registered finished, okay? And, there is one that says, of course we cannot get the logs. So that's a problem with Knative. We have a problem fetching the logs. So anyway, if that had worked, okay, that's the problem with live demos. We would have seen the output defined in the build step in this file. So this file has a set of steps. The first one, you saw the demo because it's still you, Catalin. So first step would have been echo Catalin. We would have seen that in the log, and then ls, and then bin date, right? It did work, right? No, I did it for him, So anyway, that's pure Knative build, right? So we can also deploy functions like this by registering a repo that has functions defined, a manifest for functions. We'll do the build, and then it will be served, right? Okay, well, the build for Mark has finished. If I click on this, you see that it has pushed the image to our internal registry. If I click on the pods, I should now see here, it's this one, test. And if I go back to this guy and I click on that route, I see the app from Mark, okay? But because I didn't pass an environmental variable, it's just giving me the default message. So that's the full step, right? Pointer repo, it knows how to do build. Build is internal, push to a repo, internal registry, things work. Notice that what's happening here, if I look at my pods, my previous pods here for node info and ktest, they're starting to be red in ready. That's because they're scaling down to 0, okay? So they're actually being terminated. They're scaling down. And if we wait a little bit, we'll see that they will totally disappear, okay? So we got, fancy UI. Let's talk a little bit about events now. So just deploying functions like this, it's 2019 CGI, on steroid, right? But the real interesting part is when we manage to actually start gluing those functions together through events. And we start routing events through those functions to build more interesting apps, right? That's what AWS Lambda does, and that's what I think the future of cloud native application is going to look like. So now I have, I'm going to show you how we do events in Knative, and we're just exposing pure Knative primitives, okay? It's just, nice dashboard. We have a concept of a channel, which is going to transport those events. And then we have a concept of event sources. Okay, those are things that capture events. So I'm going to create an event source. And what type of event source can you do? Well, GitHub, of course, is one of the events. So here I'm going to say, hey, you know what? I want to listen to events from GitHub when I get events, I stick them in my default event channel. What events? Well, events coming from that project, Sebastien Cloud Build, and push events. So here, basically, I'm defining a GitHub webhook, right? So I create this source, and if I go in the functions and I go see what happens, Knative has created a service. Okay, so there is going to be a webhook listening, for events coming from GitHub. So now if I go to that Sebastien Cloud Build project, and I go in the settings, and I go in the webhooks, you see that there's a new webhook that's been registered just now, test 7S7QL. This is this one, right? You see this? So what happened is that by defining this source, Knative deployed a receiver, an event receiver. That receiver is reachable from outside at that route, okay? And automatically, what's called the source controller went and registered this URL as a webhook in my GitHub repo. All right. So I know how to get event. Now what I need to do something with those events. So what I'm going to do is say, you know what, those events I actually want to dump them somewhere. So in our catalog we have a message dumper. So I'm going to just run another function which is the message dumper. Okay. So that's kind of a toy example of a function that needs to receive the event, right? And now I'm going to go in the trigger. That's why originally we called it Triggermesh. And I'm going to say, hey, you know what? Events that are in the default channel, we need to send them to our message dumper, right? So we are mapping, particular events to a function. And you can imagine in the future seeing lots of those mappings to build your entire event-based system. So I create this trigger. You see that it says channel default goes to subscriber service message dumper. Now I go to my pods to see what's going on a little bit. So first you see that my node info has started. My webhook is actually shutting down because I'm talking too much. So I haven't hit that webhook. So it's actually scaling down to 0 already. Okay. My message dumper is ready. So now what I need to go do is I need to go to my project here. This is still very much cutting edge, so I'm still a little bit nervous. So vision, sorry. So I'm making a commit. Okay, I'm making a commit. Let's do a refresh just to be clear. So refresh, what happens? First, because I made a commit, I have another build that's going on. So I have a cloud build pod that started. That cloud build pod is going to do the steps that it's in my manifest. It's a separate thing. But because I sent a message, you see that the webhook has now been restarted. It scaled back up to 1. All right. Now it went ready. It accepted the event. And it should be in the message dumper. No, it's not. Oh, I should have done that with the other platform. Okay, let's try it again because sometimes we lose events. Yeah, we lose the first event, but I don't think that's gonna work because we haven't changed the. That should have worked. Why? Okay, message dumper. It's not gonna work. We're losing the event. Ah no, here you go. Here you go. So okay, a little bit fuzzy here. Something So the pods were scaling down. We may have lost an event. It's still cutting edge. Bear with me. CE46. If we look at the CE46, that's the push that we just made. Okay, so now you're like, well, okay, all of this to be able to create a GitHub webhook. Okay, So yes, it seems a little bit over the top, but you start thinking that you have lots of things happening here that we're going to be able to leverage. I want to show you something else on our development platform, because Mark and I had a discussion yesterday about event sources. So yesterday I actually went and wrote another source. So I'm going to show you a little bit how it looks under the hood. This is the manifest for something that's called a container source. So here's the manifest for a container source. So what's an event source? An event source is nothing else than an event consumer, right? So something that's going to consume events. Oh, hey, hi, here. Something that's going to consume events. So some code that's running inside a container inside your Kubernetes cluster, right? The simplest form of event source in Knative is called a container source. And we were arguing a little bit about, do we know how to write them? Can we make it better? And so on. So here is a manifest for a container source. It's fairly simple. It just specifies an image. So that's a Docker image. It's code that just consumes event. Then it has a definition of a sink, which says, if I'm catching any events, I should send them to this sink. So here I'm sending events to my default channel, right? And then some environmental variables. That particular source is a source for Google Cloud Storage. So it's going to listen for events happening in Google Cloud Storage, all right? To be able to run, I need to give it, what project I'm using, what subscription, and then my credentials so that that code is able to talk to Google Cloud Storage, right? So I'm going to apply that, apply the source. No, not like that, like that. Okay. Get nodes. Okay, so I've applied the source, and I'm on our staging environment. So I refresh, and now what you see in the list of sources, you see a beautiful Google container source, GCS. It's a source of type container source with a beautiful little Google logo. Okay, and that source is listening for particular events, for events happening in a particular bucket. So I'm going to go in the wizard here and do a trigger default. Okay, I don't have a target service, so we go in service. We create a message dumper. Message dumper is just for testing. Okay, imagine this being your Whitefly application, whatever. I go here in the trigger. Okay, we create trigger. So events in the channel, send to message dumper, create the trigger, all right? We verify the service, we have the message dumper running, the pod is running, okay? And technically, the source is running. So I'm gonna go in my, here, Google Cloud Storage interface, and Mark, you go cloud.google.com, and then you click on console.
Search for everything.
So that's my project. I created an event subscription for this Knative bucket. And now what I'm going to do is upload a file. Vision visit. Okay, that's okay. No, that's my expense report, which I'm not reimbursing myself because it's startup life. So I'm uploading a PDF where we go in the message dumper, and bang, we see cloud event, application JSON, storage object, Knative Vision. Do you see that?
Yeah.
Vision visit PDF. So
the one thing I would just, because maybe Sebastien, he's showing the message dumper, which is kind of a quick and dirty way of just displaying on a console. But you as a developer can write anything with those. Like we probably are not creative in our demo enough to show the power of this, because you could write this kind of processing of prices and all that. We just output the console saying do whatever you want.
Yeah. So I'll finish with this, because I think this is pretty powerful, and sometimes maybe I don't convey the fact that it's pretty, very interesting and powerful. But what is this source? This source, and that was for you, this source, it needs to be Dockerized. So I have a Docker file that has packaged that source. Because I'm a terrible developer, I don't write Go, so I write everything in Python. So this is actually an event source in Python, okay?
We need more of those.
All right, so I'm importing the Google Cloud client, and then I have an SDK for cloud events, which is a specification from CNCF to be able to send cloud events in a serverless mindset. There's a hack about writing the credential because container source don't support volume mount, but it looks clean. Look, write credentials, open a file, write JSON. I have a callback function, okay, and that's it. So it's 53 lines to be able to consume events from Google Cloud PubSub, subscription, and here is the callback. So what does the callback do? It gets a message, and then it forms a cloud event. It forms a cloud event following the spec, okay? And then I just use Python request to post that cloud event to my sink, which was defined in the spec, and that's it. So it's 53 lines of Python to write a Google Cloud Storage event source. We're going to see more effort into this. You're going to see a lot more Knative event sources come into play, so that serverless applications on Knative are going to become very, very versatile and use lots of different types of event sources.
Can I just say something on the cloud events? You've seen Sebastien talk about these cloud events. CNCF basically said if we're going to do anything with portability, we have to create an envelope with defining the outer shell of what things going to be coming across the wires. Cloud events is now a 0.2.0 version. It's supported by a number of different cloud service providers, including Microsoft and others. And what it does, it defines a metadata for about what the content is. So it tells you what type, where the schema for that event is. So as those things arrive at you, you can say, oh, I know how to read it, even though you might have not intimately been aware of that. That's all it is.
So, do I get that right? And the contract between channel and an event handler is basically cloud events over HTTP, both for inbound and outbound events, like sending and receiving?
Here, yes.
But that's not the only way then? You say here, yes?
Right now, it's the only way, but it could change.
It's much more loosely defined. So what you have those channels, you have subscribers, and you have services that are consumers of those, right? So in each one of those are not aware of the other. The only one is aware of is the kind of glue that puts them together, the subscription, and that's all declarative in saying, when it comes from here, send it to here.
My code level API towards the event source or event sync is HTTP and
yeah, it's always HTTP. Yeah. It's always HTTP post right now. And reason why we wrap it in cloud events because we want to make sure that you have a chance of at least understanding what it is.
Yeah.
So I was a research guy. I think that some people are gonna say at some point that they want something else than HTTP.
So what about reliability? You were showing the webhooks on GitHub. What if actually the communication fails while trying to push the event?
That's an excellent question. So first of all, in Knative itself, HTTP is just the only implementation right now, but there's nothing saying there has to be HTTP. It's just until somebody writes another protocol handler, there is only one.
Okay.
With regards to reliability, there is different service. So I know like the Twitter, for example, uses a retries. So we do a certain amount of retries. There's a certain amount of retries that Knative sources or the event source has by default. I've noticed at least 3 that's come back if it fails. And it's Kubernetes underneath, so it has the declarative way where it's like a crash loop backup. So first one we will try right away. Okay, maybe I should wait a little, and then we'll try again. But you're right, there's no explicit foolproof way right now if the source and consumer don't declare this.
Mm-hmm.
So people like Eric Colson and others from like the NATS community from eventing, they're for example feel very strongly about the events need to be synchronous, because otherwise you're dealing with things like assurances of delivery and who takes control of that. Yeah. And if you're consuming a webhook from GitHub, GitHub is not responsible for delivering this, so Knative takes that responsibility, but we are not producer of the event, so who takes the state of the event, right? Very complex issues, and Knative wants to solve that, but it's not going to be like overnight.
Cool. Thank you so much. Thanks to Vision again and Puyo, and thanks for having us.